Okay, fraction camp. Here's another fraction routine using pattern blocks to vary the whole. So when I say vary the whole, I mean if this blue block is one whole, then what value is the green block? I'm going to start to scaffold by saying if the parallelogram, the blue parallelogram is one whole, then what is the value of the green equilateral triangle? So to do that, we compare them like this and say, oh, look at that. There's two of those green blocks. So I'm going to say that's equal to 1/2 and then give my reasoning. I'm not going to write the reasoning down. You know what it is, but I want students to write it. Remember, your job is to create routines where students are regularly comparing blocks values and then stating their values, the fractional value of blocks by saying this value is 1/2 because two equal sized pieces are equivalent to one whole. And I even want you to increase the load of academic language gradually by saying one green equilateral triangle is 1/2 of a blue parallelogram because two green equilateral triangles are equivalent to one blue parallelogram. That's a lot of academic language, and that's a huge amount of language development going on. Okay, but remember, you can scaffold them through that. It's not expected they do that in the first time around. Okay, here's another one where I say one whole is right here. So what value is the yellow block? You could probably guess without having to build it, but that's equal to 1/2. Again, notice here I have two different models of 1/2. And a teacher, remember, students are going to struggle with this at first because students believe incorrectly that a block has to have an inherent fractional value. And they might even say, well, teacher, why is it that this is 1/2 and this is 1/2? That doesn't make sense. Which one is the real 1/2? And the answer to that question, of course, is blocks only have fractional values in relation to wholes. So this one is 1/2 if that one is the whole, and this one is 1/2 if that one is the whole. That is a really critical skill set for students to be learning. This is called varying the whole, like in their brain, varying the whole. If you remember now, I want to know what is the value of that blue, parallelogram if the yellow hexagon or two yellow hexagons is one whole. You might remember this is 1/3 of one of those. In other words, it takes 3 to make one yellow hexagon, so it will take 6 to make 2. And so that means this has a value of 1/6 ... always means give me your reasoning. Okay, so here's a whole. This might seem okay. So again, here I'm kind of increasing the tolerance of ambiguity for students. Like they'll look at that and go, that's not whole. Like there's a piece missing. But I'm defining this as the whole. So how many of the green equilateral triangles will it take to make up that whole? And the answer is it would take 5, 2 here and 3 there. I could do that for you. And in fact, every single time you want students to do this, there's 2. And let's see how to 3 fit on here. I think like that. Like that. You can see now there's 5 that completely cover that whole. It's very important that they do that. And that's why these are concrete manipulatives, because you want to concretely compare the two and see that they have the same value. You can see that they're a fair trade, and that's what we mean by equivalent. And so that means this value, this fractional value, is 1/5. And give me your reasoning. All right, the purpose of this activity is to start to get students to understand that a fraction only has a fractional value in comparison to a whole. There is no inherent fractional value.